There we go. Everyone is ready. Welcome to Early. I'm DSide, and my special guest today is Michael Holdmann. Michael is a successful serial entrepreneur, accomplished salesman, and founder with over 4 startups to his name. He's been involved in the telecommunications and internet industry since the early 1980s, spanning 4, maybe 6 decades. He is credited with the founding of one of the first ASPs, application service providers, an innovation that has now evolved to what we call the cloud. He began his successful entrepreneurial career with the profitable exit from an Interconnect telephone company in Las Vegas while he was still in college. Michael is the founder and CEO of PraSaga, a next-generation Layer 1 blockchain with a focus on solving some of the limitations that currently bedevil existing Layer 1 blockchain technology. Welcome, Michael. Great to have you here.
Yeah, thank you very much. Really nice to be here.
Yeah, so going way back, what is an internet telephone company? Interconnect telephone company.
Interconnect telephone company. Yeah, thank you very much for asking that question. An Interconnect telephone company. I started in technology industry back in 1978. I was 14 years old. At the time, there was the telecommunications law was passed by Congress, and that basically divested the AT&T. So AT&T was one big company, and it split into a bunch of regional Bell operating companies.
Mm-hmm.
What that allowed, though, is it allowed other than AT&T companies to sell long distance and phone systems and such like that. And my father had an Interconnect telephone company, which was specifically that. We would install phone systems, large phone systems, PBXs and such, into hotels, businesses and such, and sell long distance services and such. So that's what an Interconnect telephone company is. And that's my career started as going through the attics and crawl spaces in Las Vegas, Nevada in the dead of summer, instead of having summer vacation between school, pulling those cable and installing those. So it's child slave labor. Back then, if you had a roof over your head and food on the table, you're working.
Well, you're working for the family business, and
exactly, yeah, you have no option.
And starting in the trenches. That's how you work your way up through a company and into bigger and better things. From interconnect, from telephone lines to the internet to blockchain. So, what was your next transition to that next step? I mean, it sounds like you were highly involved in ASPs. Cloud computing.
Yeah, so kind of between that was going between around 82, 83, and then finally into 97 is when I started within the application service provider is what an ASP is. We know it today as a cloud. But during that time, college and working at different organizations, really got into kind of advertising, promotions during that stint too, just to get some experience within there. And then got back into technology and networking, basically with a small ISP, Internet Service Provider, up in Reno, Nevada. And that's when I put together a project called DigiApp, and it was Digital Application Server, where we would host. Back then, there was PeopleSoft that is now part of Oracle, I believe, or Siebel bought them, one of them. But there were a lot of CRMs, SAP, PeopleSoft, Oracle, and such. And we would go ahead and manage and host those in data centers, and then they would sell seats for each of the users that the employer had that needed access into that system. We would sell them as a seat, a monthly seat. Yep. And that was what basically became the cloud. They just, after a while, everybody started hosting all the applications in the cloud. Once we were able to convince the CTO, CIO, that you don't have to see the blinky lights all the time on your servers to know that they're running, because we have a full staff managing those, and that's really when everything started to move forward.
Yeah, I always found it interesting. I was a physical therapist for 25 years, owned my own practice, and we always had electronic medical records. So we had a central, excuse me, a server in the office, and at multiple steps along the way, our IT guys would be like, "Are you guys ready for the cloud? Are you ready to do? Are you ready to start allowing the hosting to happen off site?" And to me, it made sense. I think I always thought that it lowered our risk. Of course, you did have to have the dependable internet connection and higher bandwidth at the time. But as those things sort of came together, it became an obvious transition for us. And it's interesting because it also, things kind of have gone back and forth from mainframes to PCs to now, then evolved to clouds, and now everybody has a computer in their hand. So.
That's one of the things that Scott McNeely over at Sun Microsystems, which was a company up until 2000. When did Oracle buy them? 2010, something like that. But anyways, he always used to say the computer is a network, right?
Yeah.
And that's basically what it finally is.
Sure.
And it's because of the approach that we've taken and the technology that we've introduced, which is the same technology everybody's been using, but I'm jumping ahead.
Yeah, well, it's a good point because how did that influence your thinking in terms of getting into blockchain?
It all started out just having that desire to create an interoperable platform where it didn't matter where you were, who you were, you had a ability to access and participate in a global community, in global commerce, and in a global economy. That's something that we're still lacking. Everything is still very siloed. I got into here through Internet of Things. After Quest Communications, which was early 2000s, one of the things that we were trying to do is consolidate everything, right? How do we move away from analog, move into digital, all of those things, and how can we create a single connection into a building where all the systems use the same exact data feed instead of having separate data feeds and such, or data access and voice access for that matter. So taking on that theme, it started to become, how do we now bring this out just not to businesses, but to consumers and such like that? I really saw the first part of that being the Internet of Things, and so IoT and smart cities. And I actually had an organization called that I started up in 2013, I think it was. And it was specifically that. It was a message bus server, and it just means it's a server that sits in the cloud that can connect all of your devices, regardless of who made the device or what platform it was on, and connect those to the back-end systems, whether it be control systems or humans that needed that data, and to be able to send commands if it's necessary, adjust your thermostat, slow down the RPM on the propeller on the ship, whatever it may be. It doesn't matter where you are or what it is. We had a system that allowed you to grab the data, model the data so that it can be used, and then transpose the data back to whatever the other system needed to read it in. Because there's many types of data models, right? You've got how many languages itself, but you also have data models. You have LAN, you have BACnet, you have Modbus, you have a bunch of them. So finding that piece in the middle that allowed you to connect those, it's kind of interesting. There was a story when I first went to Beijing, and the gentleman from the organization, I was over there on a delegation in 2016, and he talked about, the Chinese and the pen and such, right? And ink and everything. And when I was kind of thinking of the analogy that he did, in our world, the paper can be anything, the pen can be anything. And what we've done is ensure that the data that's going between those 2 points is readable by both, regardless of what they are. And I kind of use that analogy in China, and they seem to grasp onto that
Yeah.
because they're very proud of their heritage and the inventions that they've done over the centuries, right?
Sure.
And that's where I met my co-founder, David Bieberman, when I was doing the IoT, and he was at another company, and we were kind of working together within the standards bodies and such to do that. Now, what happened is we sat there with GE and Microsoft and all these big companies, and we just saw the demise of IoT because of their greed, I would say. They wanted to own your data.
Yep.
And we don't believe that. They wanted to create walled gardens.
Yep.
So that you could only use the devices that they tell you they can use, because those are the ones that they partnered with and somehow have a revenue stream between them. What that does is that limits innovation. All of a sudden, if I have Apple Home, I can only use Apple Home devices. Well, what if a new device comes out that has a better technology or is just better for me and can enhance my life in a way? I'm restricted from using that. And that's really where we see IoT, the failure of IoT being, is through the greed of the large Web 2 centralized organizations.
Right. So more than standardization, but actual ownership or custodianship of the data and the technology.
Yeah, you're producing it, you should own it, and you should get the revenue off of it. If Google wants to resell it, they have to buy it from you, not just take it from you. Just because you bought the device from them. How do they have the right to the data that's on that device, other than the warranty data, right? They just have to know what's the activity on the device in terms of being able to ensure that it stays up so it can produce the data that you can put out in revenue. And that's how we got into blockchain, by the decentralization of the Internet of Things.
Yeah, that's I've often wondered what happened with the Internet of Things, and didn't have insight into what might have been the killer. And I do see it as one of the promises of decentralization and blockchain. And is that one of the roads you're going down?
So the IoT, so kind of the story of PraSaga. We started this out in September of 2017, and we wrote a white paper that everybody loved. We brought in, we raised, there was some capital that came in early spring of 2018. And there was a simple question that was asked, and that's, what are you going to do about scale? Our first intent was take a blockchain, implement it into our message bus, so that now we have the control of the data is in order to get to the data, you got to get the public key from the person that owns a device. And then you're going to be paying revenue for that, right? You're going to pay them in order to access that data. So creating a data stream or a revenue stream for everybody on everything that you do every day. And when they asked about what are you going to do about scale, well, that was a tough question, right? It's such a simple question, and it ended up to be a 6-year project because I had a message bus that scaled more than anybody ever knew, and there was no way that I was going to be able to use any of the blockchains that were out there to try to compete with the throughput that I was getting in my message bus. So we kind of took a step back. We stopped our ICO, unlike all of the other projects out there, and we went into research, and we did about 6 months worth of research. We came up to a conclusion. Although, hey, the blockchains are great, they do what they do. You have a wallet, you get an address for that wallet that comes from the blockchain, and then it reflects assets that you have rights to in any smart contract that's out there. But the trick is you have rights to it. You don't have possession of it. You never own that item or that asset until it's actually pulled off of the blockchain. And so what we looked to do is go through everything. I've got what, 60 pages, about 40,000 words. Our first research foray, we're over 200 pages, and almost 500,000 words now in the entire design and architecture and everything. But that first part, it just came to that appointment that, or to that realization that none of these, they're good. They do what they say they do. They move a token from one smart contract to another, but they're not going to work for us. So we made a decision because we've been doing this quite some time. I stated I started at 14 in 1978. So did David Bieberman, my co-founder and CTO. He started in 1978, and he couldn't write legibly, and he was concerned about the teachers in high school going into that weren't going to be able to read his stuff. He actually went to school with Dr. Wang's daughter. So at the beginning of the summer, Dr. Wayne of Wayne Computers, he spoke to him at an orientation function, and 2 days later he received the Wang OS operating manual.
Nice.
Well, at the end of the summer, when he went back to school, there was a parent night, and he handed back the operating manual with a cassette tape. This was before floppies were involved, even the 5 1/4 inch floppies, right? And on that cassette tape was something called WYSIWYG. And that is what you see is what you get. And that's what you see on the computer is what you get on the pages being printed out. And it became basically the Wayne word processor and then the basis for every word processor after that. Dave's really the interesting one here. I mean, I've been through a lot and done things, but Dave is, as far as the technical brains here, that it's definitely him. And the other co-founder, Jay Moore, he's the baby of the group. He started out in like the 80s. Right? So, and Jay's focus has been mainly in gaming and in the gaming industry and such like that. He had a company called Garage Games in the early 2000s, which is the first ever open gaming engine. It sold to Barry Diller in 2004. It allowed developers to come in, write AAA games, independent developers. In fact, Jay coined the phrase indie dev and indie gamer back then. And it allowed, for a lot less cost. You would have to go to a studio, pay $1 million for their gaming engine in order to write an app. This is $100. It was the basis for Unity. Now, Unity IPO'd for $32 billion about 4 years ago. The difference in it was ease of use, and that's really what we got to with what we did here. We wanted to make sure that when this is all said and done, you won't even know it's a blockchain you're on. You don't have to know. You shouldn't know. You just should have some interface that allows you to easily conduct whatever type of transaction you need to conduct. And a transaction is anything. It's not just financial, right? It's buying a car. It's ordering something. It's a certificate proving that you meet all compliance within this industry or within this nation in order to transact in whatever this transaction is. So it came down to the point of we had to build our own blockchain, a native blockchain, if we wanted to do the project. So we decided to go ahead and do that and started out and filed for 4 patents. One of them has been granted in January of 2019 through March. And then that's where this really came about, is right after that, David Bieberman started looking at smart contracts. And that was the aha moment we had. Now I'm going to go back and I'm going to date myself again here. And I don't know how many people are going to understand what I'm saying here.
Well, you lost everybody at Wang Computers already.
At Wayne, yeah, exactly. Nobody remembers. There was Wayne, there was digital, everything, right? Yeah. But there used to be an operating system called MS-DOS that Microsoft used, and it was a command line operating system. There was no GUI, there was no pretty thing, there were no windows.
It was pretty.
And smart contracts are MS-DOS. You can do one application at a time. In a smart contract, it's all queued. You can do one transaction at a time. You can't do multiple. So, and you cannot shard the data on a smart contract across different shards, across different blockchains, right? And all on the same blockchain, but we look at shards as being independent blockchains that are tied together, right? But they're all PraSaga. Ethereum, they're trying to shard. So they're going to have multiple different blockchains doing work, and then they all compile to the same Ethereum blockchain. that you cannot shard that data. So you think of it as on a single processor as well. So a smart contract is a MS-DOS running on a single core processor. What we did, and the co-founders have had 21 startups, 8 exits, over 100 million over the past 3 decades. We've been doing this quite some time. And Dave, because of his understanding of the protocols that he's written, he was a secretary at NIST in the 80s. Vince Cerf was in there on the internet group. In the 90s, he wrote protocols that allowed the internet to turn into the web. That was chosen by companies like Juniper and Foundry and Extreme and such. One of Dave's first companies was in 1990 to write in applications for something called Penpoint OS. And it was just a tablet-based operating system. But the significance of that was what it was based on. It was based on an architecture that was introduced in 1972 by Xerox PARC. And it's the same underlying foundational architecture as every single Windows-based operating system: Windows, Mac, Linux, and iOS, Android. Any operating system with a Windows is a derivative of or modified version of a message passing architecture or a first-class object model. Mm-hmm. And basically, we wrote a patent, and we are now implemented and about to release a private test net of taking that first-class object model architecture and putting it onto a blockchain, implementing it or integrating it with a blockchain. And that's really the difference. So we did the exact same thing that Bill Gates did, took MS-DOS and built Windows. We took blockchain from MS-DOS on a single core processor to Windows running on multi-core processor. And that's the innovation that we have.
How is that going to affect the end user?
It just greatly enhances everything. So a quick example of what this does. So when you write an application for a device, it doesn't matter what the device is. It's got an operating system on it. That operating system is tied directly to that device, right? To the ID of that device. Yep. You can't move that operating system to other devices. In that operating system, there's that thing called the class tree, the first class object model. It's called the Windows tree in the Windows operating system. Well, when you write an application and your application has a button in it, very rarely do you actually write the code for the button. Instead, what you do is you reference class button. That's where all the code is, just sitting there. And then you say, my button is blue, it's round, and it does this when you push it. So every single application that's on that computer that has a button in it references that same exact copy of code, and they just change the parameters. Mine is yellow, it's triangle, it does this when it's pushed, right? But it's all calling that same instance of code instead of having to write their code. So you're reusing the same code. We've never been able to share those class button across devices. Each individual device has its own operating system, has its own independent class tree, and it can only use the classes from that. That is what the blockchain allowed us to do. Take that class tree, make one single instance globally of every single type of transaction that's out there, and these will build over time as people add to it. And now when somebody anywhere in the globe has, say, let's say on a supply chain, there's a part, right? And the part is a fuel injector in a car. So there's something called class part. When a manufacturer does a production run and they want to add that product, that run, to the blockchain so that their manufacturers can purchase them, see them in inventory and purchase them. Now, instead of having to write the fuel injector smart contract for every single fuel injector in production run that you do, you just call up class part. A screen pops up and you say, this part is a fuel injector. This is how many units there are. This is a SKU. This is the certificate. And this is the key thing that no other blockchain can do. It has a certificate in there that you can go back and refer to prove that that part met spec in order to be in the car. So with the spec that the manufacturer put out is now absolute, yes, you're not getting any more bad parts. You might get a bad part, but you're not getting the wrong parts. And because you don't even see it available in inventory if it doesn't match the requests that you made for it to be. And that's a big thing. So malicious code and bugs are mitigated greatly. There might be somebody that can sneak in a bad class, but the thing is, it's kind of like Linux. As soon as a bug gets into a Linux operating system, everybody knows it and they go jump on it right away. That's the same here. If there would be a bug introduced, as soon as that was found out, it's found out across everybody and they can go and reversion that class. In a smart contract platform, I don't know if the smart contract I just copied, pasted into a text editor, changed it to what I needed to be, and then uploaded all of that same exact code onto the blockchain. I'll never know if there was a bug in that original smart contract. The bug is just going to hit and it's going to do whatever it did to my account to the account that it did before. And now imagine if you have 10,000 smart contracts that copied from that original smart contract. That's one of the differences there. The other difference is just go to market. We just created an instance. As long as that class is already written, you might have to write the class, but once it's there in the class tree.
Yep.
Now it's just, all I'm doing is I'm describing what my thing is. And it can be a security, it can be a certificate, it can be a part, it can be a NFT, it can be whatever you want it to be. There's nothing holding us back. And that's the other thing that we really focused on here. You know, this industry has kind of cornered itself into a total addressable market of 4% of the world's population. In all the people that are ever going to be interested in NFTs, DeFi, and trading are in the market. There's no new coming in. I mean, now you have projects or chains going out to other chains and bastardizing their projects, right? I mean, what was it? Polygon went and paid $3 million to Utes in order to move off Solana or whatever. I mean, there's no new projects coming in, and that's because the world, the majority of the 8 billion people out there are more concerned about milk. How am I going to, get into work, tuition for my kids, all of those other things that we have to deal with every day in life. And that's what we're here to address. That's what we really made. How do we address that other 96%? Because blockchain is a fantastic technology. It can do much good for the world as far as immutability, transparency, security. All of those things really are real effects of blockchain. It's just we have to make sure that, and I refer back to the internet. In December 5th of 2020, there was a headline in a newspaper that said, millions leaving the internet in droves, no utility, no value to the average user. And one of the approaches we're taking is through enterprise. I always refer to this. It wasn't until something came out that affected my life. I go to the banks. As soon as they launched an application that I no longer had to drive down to the bank and to do a wire transfer. I no longer had to call and listen on the phone for 15 or 20 minutes, do my transactions in order to balance my check register between statements coming out. That was utility. That's when the internet started to thrive, when it was something that could affect my life positively and give me more time to, although actually it's not more time anymore right now. That's all we do.
Find other things to do,
to make it easier, your life easier, and give you more time to live.
Yeah.
But now we're just on social media. But that's really what we're addressing here, and we believe that that's going to be the way to the general mass population as well.
Is do you see PraSaga, the SagaChain, being utilized by consumers or retail facing or just general public, or is it more enterprise solutions to serve the public?
No, well, in the supply chain, the end user is a customer, right?
Yeah.
So when you build that car and then you transfer that car over to the user is going to get that transfer over on the blockchain. Now they have their own account. This user has an account with a 256-bit or string of alphanumeric characters that are randomly chosen, won't be repeated for billions of years. That's your ID. That's your identity. It's a decentralized digital ID. In our world, because we got rid of smart contracts, every asset that you own is a subset of your account. That asset has its own 256-bit string unique ID that won't be repeated. It's a globally unique ID. And so when you go to purchase a car now, the dealer can actually take that car and transfer that object from their account into your account. Yeah. Now, though, what I have is I have my car. The VIN number is now that 256-bit string, right? But I can click on that and I can see every single part. I can see every single component of every part. Yep. I can see every certificate proving that part had the right, that met spec to be in there. And every manufacturer and every supplier that ever touched my car.
Yep. And every person every robot that's screwed
absolutely.
in.
You have the identification of
labeled
everything.
and identified.
So
nice.
Everybody knows where to go back to if something happens. It helps with recalls for enterprise, and which is safety for the public, because now it goes to a point of you didn't put the wrong part in there as long as the certificate authority didn't lie. This now becomes a 1 in a million. 1 in a million parts are bad, right? That's just an average. We've been saying that forever. Yeah. And now it just becomes that point. And for the consumer on the warranty and such like that, everything, there's no more arguments. No, this is under warranty. You got to pay for it. It's proven. I have an immutable record of everything that happened, how it happened, when it happened.
Yeah.
And that's where it really does add to the consumer. And we can get into our our SagaChain management policy to enhance more what it does for the consumer, but I'll let you go.
Well, I want to take a step back. Who are you partners on this?
Huh?
Who have you partnered with on this? So
in partnerships right now, we've got 6 projects that are building on us.
Yep.
3 of them came out of the Consensus Web3-a-thon in Austin last year.
Nice.
And then we've got 3 that we have signed memos of understanding with, and a broad range of things. We have one that's a medical device manufacturer and does a blood oxygen or blood I think it's glucose measurement. So they're using this both on the supply chain side as well as on the data side when they're collecting the data from the remote access in order to make sure the data is secured and such. We have My Data. My Data is a platform that's going to allow you to now lease or rent your data instead of just one-time sales, so that you can have recurring revenue off of here whenever somebody wants it.
When you say your another data, healthcare data or consumer
whatever data is that you want that you're storing on My Data, right? That's basically, I believe it's your choice on what type of data you want to store.
Yeah.
But yes, your healthcare data would absolutely be not on the blockchain. And we got to straighten something out on this with this industry. The data is not on the blockchain. It never should be. Yeah. It would get too big, right? The data is somewhere, but the only way to access that data is through a public key that's given that accesses through the blockchain. So the hash of where that data is on the blockchain where it's stored. And then the only way to access that is through there. So you have full control over all of your health data now, and you're storing it. You have it somewhere, right? It's not sitting in a doctor's office that then you have to go and sign in order for that doctor to send it to that doctor. But that's a big point of what that data is. It could be anything, right? Yeah. And then another interesting one is something called Animal Cloud, and we have one on the Consensus side saying Forever Friends, and the Animal Cloud is actually has contracts with the Department of Defense in the United States for tracking of military service animals, and then Furry Friends has they're utilizing our blockchain in order to track pets or animals from shelters and such and homeless, so that they can find homes and such like that. Yep. So we have manufacturing, We have healthcare. There's actually an app that allows you, that's building on our blockchain, that allows you to make doctor's appointments, has your HIPAA information stored, and meets HIPAA standards because of the encryption and all of those things, and the way that you get into blockchain. So it shows a range, other than NFTs, DeFi, and trading of a coin. It shows a range of industries that are able to build. And then finally, and I can't say the company, we're about to announce something on it soon though, but getting into rights management, royalties, and payroll across entertainment and gaming. We can actually track, they have major problems in this industry. They have a lot of stuff is still done manually. We automate a lot of those tasks.
Mm-hmm.
And that announcement will be coming out within the next few weeks on the projects that we're working on as far as that industry goes. And we've got a fairly large, we've got two fairly large companies. One's a $1 billion company, and another's a $6 billion enterprise. And they'll both be announcing that they're going to utilize our technology in order to, or our blockchain, in order to really automate a lot of the manual process that they have in their ERPs and such. And their ERPs are enterprise resource planning.
Yeah. Are there people using this blockchain yet?
No, not yet.
So
we just, in fact, we're just about to announce, and I'll make the announcement here, a Learn and Earn program. Details will be forthcoming. We chose Python for our programming language.
Yep.
We chose Python for two reasons. First reason is 85% of the world's developers consider it their main language. So why not, right? Why have a small pond of developers when you can have the entire ocean full?
Sure.
I think one of the issues with blockchain, other than no composability between smart contracts, is the entry level. The cost of entry for to hire a Solidity developer or Haskell or Rust. They're all charging these or demanding these large fees. That really does put up a barrier for entry. The other reason we chose Python is because Python is known as they have a first-class layer in their programming language. And that made it the easiest language to modify into a first-class object model architecture. So there's a technical reason.
I don't know what that means. Can you explain that?
Yeah. So in object-oriented programming, you have classes and objects, right? And the programming languages, so like, for instance, and this is what I'm not a developer at all, right? I just go off of what Dave says, and hopefully I remember most of what he says. In Python, when they have this first layer of classes, that means everybody using a language can use those classes, and then you write your own classes that only you can use.
Yep.
But that first class layer is that layer that's fully dynamic globally, right? Available. In Python, when you go and pull down, they have libraries, class libraries. And when you want to use the code in those libraries or the functions of those libraries in that code, you just reference them, but they actually pull that code down into your program. In our world, instead of referencing the Python classes, you're referencing the classes in that single instance global class tree that we have. So now you have your account, a transaction comes into your account, and you have to run a certain code, a script, in order to execute that transaction. Well, what your account automatically does is walks up that class tree, finds the class that's in that single global class tree that has that code in it that you need in order to execute that transaction. It pulls down that code, instantiates it temporarily into your account. You run the application, or you execute the transaction, and then that code goes away and just sits there up in the blockchain waiting for you to need it again. So that's really the difference. Instead of pulling code down and storing it, you're just using it temporarily and then lending it back. Right. And so and if there's 400,000 different transactions of that same type going on at that exact same time. They're all using that. They're all just instantiating that code. They're not waiting for the person before them to get done with it, and then they can use it, and the next person can use it, and then the next person can use it, as is in smart contracts.
Yeah. So it sounds like part of the strategy to increase adoption is to make it accessible to builders, to developers.
Absolutely.
What other strategies or what other approaches are you taking? The standard approach of an ICO, of incentivizing participation, things like that, or what other strategies?
Yeah, so we have we'll be launching a private testnet within the next week or two, and we're going to do a bug bounty on that. We're also going to do a code bounty off the people that do Saga Python. Go ahead and start to build classes. The main focus areas that we have to build in is we need community built. We have like 28,000 Twitter. We have 7,000 or so in our Telegram and such. But we really need to build that community now and get bring in not maxis, but you almost need maxis, right? So they're out there talking about your project and such like that. And then miners, node operators. So we are a POS and PoW hybrid. You do need both in order to mitigate both types of attacks, short-term and long-term. So we're looking for developers, projects, miners, and then community.
Why hybrid?
Well, so POS is great for short-term mitigation, attack mitigation.
Yeah.
However, every blockchain still has all of the keys referenced on their blockchain. You can go back a year, 2 years, get the private keys from anyone that participated in that block, right? And they're miners and such, and you can track people. This is what hackers do, right? You get those keys from that block. You can start a new block there with those keys, and you can do the work, become the longest chain. Everybody that had any new node coming on is automatically going to go to longest chain as default for blockchain. Sooner or later, the old nodes will come over because that's where the revenue is. And you've just taken over ETH2. PoW, that is the only guarantee against long-term attack, because once the chain is too long, too expensive, because you have to put the work in order to do it. So with the way that our chain works is you do, each shard has 256 nodes on it. There's a leader for each shard. The leader, transactions come in, the leader builds a block and he sends it, and he wants 21 random, or 22, I don't know what Dave came up with, random nodes to go ahead and sign that. And BFT consensus is reached, the block is produced. Then every single node on that shard, all 256 are miners. They all now compete for 15 seconds to run the hash algorithm to secure that block. And then we go ahead and redo. So the first thing there, the block cannot be forked because the miners aren't not the ones that produced it. They're just securing it with the hash. The POS actually did it. Now we have to get around but the keys are still out there. Well, after the POW is done, the signatories come back in and just say, yes, the POW is done on here. And then that hash is given to the leader. Well, we can throw out all of the keys from the POS signatories because the POW did the work on it. So we don't have that potential vulnerability of going back in time, getting private keys, starting the block and going, because those keys are not relevant anymore. And then what the leader does with that hash is it braids it with the hash from all of the other leaders on all of the other shards. So now what you have, and we relate this to, say there's 10 shards, and we can do up to 65,000 shards, by the way. The technology internally on the LAN inside the data center just isn't there yet in order to handle that type of a thing. So say there's 10 shards or 100 shards. Let's just say 100 shards. I'm doing 4 blocks per minute on each shard. times 100 shards, right? So I'm doing 400 blocks per minute times 10 minutes. So now for each individual Bitcoin block being produced, I have the same level of security, but I'm producing 400 times more. And that means that the per block power consumption is 400 times less than a single individual Bitcoin block. So we're still going to use the same amount of power. 10 minutes of work is 10 minutes of work.
Right. To produce
the thing is, how do you make that work more efficient?
Yeah.
And that's what we've done.
Does that, okay. I was going to ask if it slows down transaction time. But it sounds like once the blocks are produced and the nodes are connected to that.
Yeah. We will be doing on average 1,000 transactions per block, one block every 15 seconds per shard.
Yeah.
So you go. We can handle all 8 billion people doing retail transactions on our blockchain. We can scale to that.
All right, let's see it happen.
I would love to, right? I mean, that's the thing. I was looking, everybody's about Visa and MasterCard and everything. So I went in and looked, and in 2020, there were 467 billion transactions done in debit, credit, and prepaid cards.
Yeah.
And that's global, right? So that's Unibank and MasterCard and Visa and everything. Well, if you go down to that and spreading it down, that's 14,000 transactions per second.
Yeah.
Well, on a 1 gig bandwidth network, that would take up 15% of our total capacity of the blockchain.
Yeah. Yeah.
And yes, that can be done. It took a while to do it. We had to design a multi-core processor, which means that each shard is its own individual blockchain producing a block, but you're melding them all together by sharing that hash power. So just like in a multi-core processor, as long as the data that you're using is separate from the data that the other core is using. So core has to use the same data, you're in queue. You have to wait till the first core is done and it goes to the second to third. But if it's all separate data, then they can all run independently and process independently. That's the same thing here. And that's one of the mistakes that every single blockchain has made. You know, we have a saying that we use a quote very often from Einstein saying, you cannot solve problems using the same thinking as when you created them.
Right.
Every single project out there is trying to fix smart contracts by sharding the consensus without realizing that smart contracts are the main issue stopping scale in a blockchain. And it's the data that has to be sharded, not the consensus. And that's what we've done, is we've taken that whole different approach. We talked to a Core Cosmo dev the other day, and he's like, you guys are 180 degrees from everybody else in this industry.
Is that going to scare tech people?
It should scare tech people, but it does, well, let's look at the industry.
Like how do you get
There's only
0.1%
of the industry is tech people, right?
Yeah.
Everybody else are traders and such. Are they hesitant to it? Well, I think there's two things there. First of all, yes, because they've been told a different thing for so long that they believe that and they don't want to believe that.
When I say tech people, I think I'm referring more specifically to miners.
To miners? No. So miners will, I mean, they're the recipients of inflation, right? We will always mint. The miners will always receive rewards. Now, we just released our management model for SagaChain, which we also have a mechanism so we can dynamically burn in order to create a stabilized purchase power. But we will always mint coins. So the miners will always they don't have to worry about, okay, well, only the transaction fees going to cover my costs. You will always have minting and rewards that go along with those blocks that you're producing. You're competing against a lot less people. So now as a miner, instead of competing against 100,000 miners that are all going for the same Bitcoin block, you're competing against 256 miners that are trying to do that block. And the way that we have it split up, the rewards are split 30% go to the signers, to the PoS validators, those 22 validators plus a leader, 70% goes to the miner that wins that. So you always get your transaction fee. You're always earning rewards. It's just what is the level of reward that you're earning.
What sort of risks do you see? What are your top 3 concerns going into the next few months? Or challenges?
Well, yeah, the main ones are regulatory, right? I mean, we are a Swiss foundation. It killed me. We got our the patents were granted here in the United States, but we assigned them all to the Swiss foundation.
Yeah.
So we are a full nonprofit Swiss foundation. We are we'll have a DAO once voting starts. The foundation, the IP was assigned to the foundation. The community actually owns our IP. Unlike Hedera, where they set up an enterprise, a corporation, put the IP under there, and it did this blockchain, right?
Yep.
We have the community owns the IP. Regulatory wise, it's just we don't have anything to do with the U.S. We have no U.S. participants in anything. But it's still just scaring people from the industry, and that's my biggest thing. The more fodder they put out there, the more FUD they produce, the more skittish people get, right?
Sure.
The other thing is not, just getting the understanding of what we've done here and, what the change that this really is, because we're not just changing blockchain. We're actually changing the way the world computes. And yes, Scott McNeely, the computer is the network. Yeah. We've just made it that. Right. And that's the thing. How quickly can that attrition go? We do understand that in the first year or two, it will be more, the demand for the coin will be more speculative driven until the supply chains and such turn up. But we absolutely see this transitioning over to the demand for it comes from General Motors when they have to go in and in the morning, buy the Saga coin that they're going to need in order to complete their production runs that day and pay all the transaction fees. The nice thing is, in this world, a supply chain is very timed. Everything times out exactly. They know exactly how many pieces they're going to make. Right. They know exactly how many transactions. So they can go in beforehand, purchase a coin and make sure they have enough in order to cover all transactions for that day of production.
Or that month.
Right.
They're not doing transactions on a daily basis. It's all programmed.
Well, no, actually, it would be a transaction. Like if you're moving a device, if you're moving a product from the dryer to the conveyor belt, that's a transaction because that's a new machine taking over that has to do this run. Okay. That would be a transaction on the blockchain. That was, yes, this did hit timing. I mean, it gets the data granularity that we're able to offer the world is incredible.
And what about healthcare adoption? Healthcare tends to lag in all technological adoption. How do you plan to convince the healthcare industry that they need to get on the blockchain and enable people to custody their own data, their own information?
Yeah, so that's we have one of our advisors. It works. He's got his PhD in pharma, and he's been in the industry for 15 years, working with both pharma, phase 1, phase 2. Mainly, his concentration has been in pharmaceuticals testing, and also regulated medical device. So we already have, like I stated, Telebionics, which is that one that's doing the manufacturing and blood glucose. We are speaking with other pharmaceutical organizations because they do see the immutability, the transparency, and such like that. So we're starting to make entrance into there. Once they understand, and I think coming through rights management and royalties and entertainment and gaming is going to wake up healthcare as well. Because if I can ensure that the royalties on here, and if I can ensure that you don't get to play this if you haven't done all the things that need to be done for you to access this commercial GE in order to run it, because in the past, actors aren't getting paid. They're not tracking every single television station globally and knowing when the commercials run, right? This really ensures that. I think once everybody starts to understand what this capability is, we'll get more, it'll come over more. But the HIPAA thing is huge.
Yeah.
It needs this, right? Because
Oh,
you
yeah.
still don't have control of your records.
That's right. That's right.
Not
And
yours.
it's such a hassle for patients and for providers.
Yeah, exactly.
And actors getting paid. There's a Seinfeld episode where Jerry gets paid per episode from episodes that ran in Asia. And he ends up getting carpal tunnel syndrome from signing 1,000 checks for 10 cents a piece. So I think blockchain solves for that.
Yeah. The jerk too with Steve Martin, remember? When he had to take back for the nose.
That's right.
Everybody went cross-eyed. Yeah.
That's right. That's right. Great invention. Anything else you want to add? I mean, this has been tremendous. I've learned a ton today, and I'm really excited for what you guys have developed. And I think you're onto something that solves for a lot of problems out there. So yeah, and you mentioned the logo, and I want to bring that up real quick because this is what our mission and vision is captured in that icon. So that icon is not it's not 2 infinity symbols, although that's what it looks like. It's actually 4 P's. And that stands for purpose, people, planet, and philanthropy. And that's exactly what this whole project is about, right? To create an interoperable platform, an underlying foundation for all transactions global, whether they be financial or other types of transactions, your HIPAA records, right? And allowing somebody to see those. We're also doing this with we took a different approach to coin. We're not here to, win 1,000x, win 10,000x and such. Right. We're actually looking to eventually have a zero inflation, zero deflation coin supply. So that it's based on the velocity of the transactions going through. One of the things we can do that no other blockchain in the world can do is I can measure GDP and CPI internally on my blockchain. So we can actually get to that point where it's kind of like a casino. Yeah. Got chips on the floor. You better have enough money in the vault to cover every chip you have on the floor. You don't need any more, and you can't have any less. Same thing, right? And that is going to allow a method of exchange globally where people can trust. And even with everything going on with the banks and such, what if you could have your cash on a blockchain with zero inflation, zero deflation, and then when you needed to convert it over, right now you would be gaining 6% on the US dollar by having Saga coin with this stabilized purchase power. When you have to buy something in fiat, you're moving it out there into fiat and you're using that. But this could eventually be a bank account. Your bank account is not paying. It's not the 15% we used to get in the 70s on the savings account, right? Yeah. Now you're at 1% or less, and and inflation's at 6%. So you're losing money by keeping it in the freaking bank, and they're charging you fees. Now you're getting me excited. Yeah. This is the biggest part of this whole thing. Yeah, that's pretty cool. And I like the casino analogy from the Vegas guy.
Yeah. Well, it's what I know, right?
Tremendous. Great conversation, Michael. It was really good meeting you. Sorry about the technical glitch at the beginning, but we recovered pretty quickly.
That's cool. No problem. I just have to figure out how to use. I hate Google products.
Yeah.
I stopped using Google as soon as they took their tagline, "Don't be evil" or "Don't do evil" down, right? It's like, well, that's like the greatest tagline in the world. How do you take that away? What are you going to do now?
Who decided to get rid of that? Where can people find PraSaga? Where can they find you? And what else do you want listeners to know?
Yeah, no, absolutely. So PraSaga.com is our website.
Yep.
Telegram, we're PraSaga Official. Twitter, we're PraSaga Official. YouTube, I believe we're PraSaga or PraSaga Official. It's one of the two of those all the time.
We'll put them in the show. We'll put them in the show notes. Nice.
Yeah, and go look at our stuff. follow the project. We will be launching and listing sometime midsummer so that there's accessibility globally for people to participate. Until then, we do have, for those outside of the United States, we do have a private sale because we are looking for validator or node operators during testnet. We're going to have only 1,000 so that it's manageable, but we can still be global to make sure that everything does work. You know, I mean, you can't testnet in a single rack in a data center where the two computers are attached together directly and go, oh yeah, I simulated a global. No, you didn't. Right. Yeah. So we want to do that and then run that until mainnet. So we have a lot of opportunities here. We have opportunities for developers. Come and learn Saga Python. Yep. We're going to have a lot of enterprises that are going to be looking for resources in order to write their apps. We have a community. We want to build community. Everybody, we're here for you. We're building this whole thing for you. Everything that we've done over our lives, and there's a lot that we've been involved in, and innovations, we're putting all together. So it's all this technology that you've always been using all your life that is just coming together the way that it should. And blockchain, the capability of the distributed ledger allowed us to do that. And then the third thing is, projects come and build. We have projects that are starting to call us and come over. And I guess this is the biggest concern, back to your question. I didn't go out and raise hundreds of millions because I stopped my ICO. So I don't have millions of dollars to grant project to steal over. We do have 42 funds that have participated with us that would love to see your project and see if they would be willing to engage and back your project. We do have, we will be listing soon. The coin is not liquid yet. I do have grants with the coin, but I just don't have that fiat, right? In order to do it. And it's because we shied away from those large investors that want big chunks of money and better terms than everybody else so they can dump on you. And, we're just here to serve. So all of those things are very important. And any projects that are out there, please come to us and let's see what we can do in order to make sure that you're able to get up to the point and where you can liquidate any coin that you have.
Yeah, that's great. I mean, your experience in this space and your team's experience should serve you well. You've seen the mistakes. You know a lot of the pitfalls. There's always other bumps in the road, but
everything repeats itself, right?
That too. That's right. So you're ready. It sounds like.
That's awesome. I really appreciate that.
Yeah, man. Great chatting with you. Great meeting with you. And let's catch up in a few months.
Yeah, no, perfect. I would love
I'll be watching everything you do.
You're awesome, man. Hey, thank you so very much.
You got it.
Have a great day.
You too.